Hey guys, this is going to be our first virtual video, so you'll have to let me know any feedback that you guys have or things that you would like me to do differently. I know a couple of you leave your notebook at school, no worries. Those of you that have it, I would highly suggest that you do take it out, and I suggest that you guys follow along with me by taking the notes. You can use the notes on your quizzes and tests. You can also use them for your assignments. And I think if you do actually take these notes, it'll make the assignments, quizzes, and tests that much easier. If you don't have your notebook, just take out a piece of paper. No worries. So we're going to be talking about our next unit. It's polynomials. It's going to move pretty quickly. We're going to do it in, a week and a half, not even. So there's a couple definitions you need to know, and then there's a lot of vocab you need to know. So this whole first little bit is going to be a lot of the vocab, practicing naming, and then we're going to add and subtract. That's all we're doing today. So the first one is, what's a monomial? So a monomial is an expression that is a real number, variable, or mix of both. So an example of that, would be something like 2, right? That's just a real number. It could be x, which is just a variable, or you could see 2x. Next, a polynomial. Well, many of you probably from other classes have heard the prefix poly before. Poly means many, okay? So a polynomial is the sum or difference of monomials. So if I use the same example from above, instead of having 2x and 2x all separate, this is a monomial, this is a monomial, this is a monomial. If I wanted to make one big polynomial, I would say 2 and then maybe plus x and then maybe minus 2x. So this whole expression is the polynomial. Okay. Now, when you are looking at polynomials, there's going to be a couple things that they ask you to do. The first is that you write it in standard form. When I wrote this one right here, one, it's not simplified, but it's also not in standard form because that was just an example. So standard form of a polynomial means that you write it in descending order by exponents. Descending means that you start with the biggest exponent and you go down to the smallest. So an example of this would be 3x3 minus 2x2 minus 4. So I have a big exponent of 3. I write that first. Then I write the part that has an exponent of 2. Then this one doesn't have an exponent at all, so it goes at the end. So that would be standard form. Now, there are going to be points where you're going to have to pause the screen so that way you can take down all the notes because you're listening and watching me write and writing yourself. You have to make sure that you're monitoring that on your own because in order to make this not be a super long video, I'm going to keep moving through. Okay, so once you put it in standard form, there's 2 names that associate with each polynomial. You get to classify them by term and degree. Most of the time, you will classify the degree first. So we're going to make a little table that has the names for the different types of degrees you will see. Now, degrees is going to be another word for exponents. Okay, your table does not have to be perfect. So any exponent. So for example, this has an exponent of 3. So I would need degree 3 because it's the largest. So I'm going to start with 0, and we're going to go all the way to 5. Now, after 5, there's a certain rule, but I will fill you in on that. So if there's no degree, basically, if I just gave you -4 and I said name that, there is no exponent. When there is no exponent at all and it is just a number, which we call a constant, that means that the word is also a constant because there's no exponent. If your largest exponent is 1, that name is linear. If your largest exponent is 2, that's called quadratic. If your largest exponent is 3, that's cubic. 4 is quartic, so with a Q. 5 also is with a Q. It's quintic. Now on your assignment, you're going to have to type these into Edulastic. You want to make sure you are spelling them right so you're getting in the correct habit. It's not multiple choice though. So you have to make sure that you have them down the right way. This is why it's important to take the notes. Now, anything after that, say it's like 6, okay, is the biggest exponent. You just say that's the 6th, and then 7th, 8th, so on and so on. Okay, so anything after 5 doesn't have a special name. So that's one part. So this one, having a largest exponent of 3, because that's where you're looking. You look at the first term in standard form. This would be called cubic. Now that's one name for this. This is a cubic. Then there's another name. The other way you classify polynomials is by the number of terms. So we're going to make another table for that. So number of terms. And I'll give you the name. Now this one isn't as many. You actually only need 4 for this one. And I probably should have made the name a little bit bigger on my side, but I'll make sure it fits for you. So the number of terms, you either have 1, 2, 3, or you have 4 or more. Now, you should know this from the definitions before. If there is one term, like above, something with one thing is called a monomial. I don't know why my green pen isn't working today. Monomial. Look at, I even just spelled it wrong. Monomial. If it has 2, it is a binomial, just like a bicycle. Binomial. If it has 3, it's like a tricycle. It is a trinomial. And then if it has 4 or more, it would get really annoying to name these over and over again. Many, okay, 4 or more, it's called a polynomial. So the same word we represented before. So the only time you have to worry about giving it a specific name for the terms is if it has under 4. If it's 4, 5, 6, 7, etc., it's just a polynomial. This might be where you want to pause your screen to make sure you have down the table and the spelling. Now, we're going to look at some examples, and I'm going to write them with you. Okay, so, and I don't really have that much room left on this page, but I want to make sure I have the tables. So the first one will be 11x to the 5th plus 3x to the 3rd. Now, this is already in standard form because it starts with the 5th power, and then the only other term has the 3rd power. So this is in standard form because the biggest is 5. So when I want to name it by degree, I look for the largest exponent. The largest exponent is 5. So I go to my table, degree 5 is quintic. So one word for this is quintic. But I also name it by the number of terms. Well, one way to tell the number of terms is wherever there's a plus or minus sign is to kind of draw a line down. So I have this term here, 11x to the 5th, plus this term here, 3x to the 3rd. So I'm basically adding together two things. That means that there's two terms. So if I go up to my two terms, it's called a binomial. So the whole name for number 1 would be a quintic binomial. Quintic for the degree 5, binomial for the two different parts being added together. Okay, example 2, I'm going to kind of come back over here and kind of do it a little backwards, but that's okay. So example 2, 6x minus 4x to the 2nd plus 1 minus 3x to the 4th. Now, right away, this is not in standard form. That means you're going to want to write it in standard form. So if I look at the exponents, this one, it doesn't have anything, but there is a variable. That means there's an imaginary exponent of a 1. So this has a 1, this has a 2, this doesn't have any variables, and this has 4. So that means this is our largest, so that's our first one. It's called the leading coefficient. So I should rewrite that first. After the 4th, the next largest one is out of these 3, so it's the 2. Now be careful, it's a negative, so I'd put minus 4x to the 2nd. So now I move that one and this one. Now I have 6x or 1. Well, this has the variable, so that goes next, and it's positive, so I put plus 6x. And now the last part is just the 1. The lone number goes at the end. It has no variables, no exponents. Now this is in standard form. So now if I look at my largest degree, it's 4. So if I look at my list, that's quartic. So this is called quartic. And then I look at my terms. Now this one's a little different. I have this term, the negative 3x to the 4th. This term, minus 4x squared, plus 6x, plus 1. So that's 1, 2, 3, 4 things. So that's 4 or more. So that would be called a polynomial. So for our example 2, we would name this a quartic polynomial. Now, up to here, this is half of the work that you need to do for this lesson. You need to be able to name them by degree and by term and be able to put them in standard form. Be careful, make sure you don't forget any exponents or change any signs. The second part of this lesson requires you to add or subtract polynomials. Now, as we have done before, you can only add or subtract things that have like terms. That the same rule goes for polynomials. So, I'm just putting a new header because I had to go to a different page, add and subtract polynomials. Remember, you can pause at any time and then come back so you're caught up. I'm only going to do a couple examples with you guys, and I will practice naming them also, just so that way you get in the habit, but I don't want this video to go too long. At the bottom of your calendar, there's extra videos for you to watch. So we'll do a basic one and then a little bit of a harder one. So the first example is going to be 4x minus 3 plus 7x plus 8. Now, whenever you see parentheses, you should automatically be thinking that you have to distribute. There's a positive sign here. Technically, there's a 1 out front. That means I need to distribute here and here. There's nothing for me to do with this one. That means I can just drop the parentheses and write 4x minus 3. Now this is positive 1 times 7, so that gives me positive 7x. Positive 1 times 8 gives me positive 8. Now, as you have done before, you can only combine things that are like terms. Like terms means they have the same variable. So in this case, 4x and 7x are like terms. So I can combine them and get 11x. And then -3 plus 8, you should definitely be using a calculator, combine and give me +5. This right now is in standard form because this is the thing with the variable. This doesn't have one. So here's my standard form. If I wanted to name this, I would say, okay, what's the exponent here? Well, there isn't an exponent, but there's an imaginary 1. So if I look back at my list, anything with an exponent of 1 is linear, if that's the largest exponent. And then I have 11x being added with 5. So that's one thing here, 11x, and one thing here, that's 5. And the word for two things then is binomial. So this gave me a linear binomial when I added them together. So this is pretty basic because it was two things, a binomial plus a binomial. Not too bad. Okay, now if I make it a little bit longer, if we do 4x squared minus 8x plus 3 minus 2x plus 6. So this should look a little different because now I have 1, 2, 3 things, so that's a trinomial, minus 1, 2 things, that's a binomial. These are the words you're going to have to start using. Again, there's nothing to do with this parentheses, so I could just copy this down without this parentheses. There's nothing in front of it to distribute. But here, there's a -1. That means I have to distribute like that. So I get a -2x. -1 times +6 is a -6. Now here's where people kind of mess up. They'll say, okay, well, my like terms are this and this. But the problem is that's not the thing with the biggest exponent. And if you want to write it in standard form, you want the largest exponent first. So you want to look at this part first. And you want to say, is there any other thing with an exponent of 2? No. So I'm going to copy that down. Now, is there any other thing with an exponent of 1? Yeah, -8 and -2. That's -10x. Then there's the 3 by itself and the -6 by itself. So if I do 3 minus 6, I get -3. I can't combine any of these because they're not like terms, so that means I'm done. It's in standard form because it has the biggest exponent first, then the 1, then the none. So this one, if I wanted to name it, the largest exponent is now a 2. So that word, if you look back, is quadratic. And now there's this part, 4x squared, minus 10x, minus 3. So now there's 3 things, and 3 is trinomial. Okay, last one. We're going to do a trinomial minus a trinomial. Okay, -2x plus 4 plus 5x squared minus -7x squared minus 5x plus 4. Let me zoom out a little bit so you can see the whole thing. So same rules apply as before. There's nothing to do here, so I can just copy it down. And here I put my -1 and I distribute. -1 times -7, positive 7x squared. -1 times -5, positive 5x. -1 times 4, -4. Okay, so if I start to combine like terms, I circle this one, -2x, and I circle this one, 5x. So that gives me 3x. Okay, positive 4, -4. Well, that gives me 0. So I don't need to write anything. 5x2 plus 7x squared is plus 12x squared. Now this is great. I combined correctly, but this is not in standard form. So I would not want to leave this alone. This has an exponent of 1. This has an exponent of 2. That means the 12x squared should be in the front. So really I should write 12x squared plus 3x. And that's what I should box. So if I go and name this now, the biggest exponent is 2. So that means that's quadratic again. And there's 1, 2 things being added together, so that's a binomial. So it's always important to write in standard form. So that's all I have for adding and subtracting and naming. Please make sure you pause and you took down all the notes. Good luck on your assignment. Let me know if you need any help.